Hey there. As someone who trains people on AI and machine learning, I get really excited when something truly new comes along and just changes the game. And today, we're going to talk about one of those game changers, graph neural networks. Now, this might sound like something straight out of a sci-fi movie, right? But it's not. Back in 2020, this actually happened. A powerful new antibiotic molecule called halicin was discovered. And the crazy part? An AI found it. So the big question is, how? The answer isn't just about throwing more computing power at the problem. Nope. It's about a totally different and honestly a much more natural way of looking at the world. It's not about neat and tidy grids of pixels, but about seeing everything as this complex, interconnected web of relationships. Okay, let's really get into this. For a long, long time, AI models like convolutional neural networks, CNNs, have been the absolute rock stars when it comes to understanding structured data. You want to find a cat in a photo? That's a CNN's bread and butter, processing that grid of pixels. And this is where we see the fundamental difference. A CNN looks at a picture kind of like you'd read a book, page by page, in a fixed order, looking at little groups of pixels. But a GNN understands things more like a conversation happening across an entire party. It's listening to everyone at once. You see, the real world, from our friend groups to the molecules in our bodies, it's messy, it's irregular. And GNNs, they are built for that beautiful mess. So to work their magic, GNNs use something called a graph. Don't let the name throw you off. It's a super simple but really powerful idea. You have your entities, the nodes, but instead of just looking at them in isolation, GNNs focus on the connections between them, the edges. That's where the real story is. The core logic that GNNs use is something we all get intuitively. It's the idea of homophily. Birds of a feather flock together. If you're on a social network and, say, all of your friends follow the same band, a GNN can make a pretty solid guess that you might like that band too, even if you've never said a word about them. Okay, so how does a GNN actually take this simple idea and turn it into a learning algorithm? Well, it's not nearly as complicated as it sounds. The process is actually pretty elegant, and it's called message passing. Think of it like a little three-step dance that every single node in the network does at the same time. First, each node listens to its neighbors and gathers up what they're saying. Then, it takes all that neighborhood gossip and combines it with what it already knows about itself. And finally, it forms a new, more informed opinion. So, what happens when this dance keeps repeating? Well, when you repeat this process over and over, that's when the magic really starts. Information spreads like a wave across the network. After round one, a node knows about its friends. After round two, it knows about its friends of friends. Do this a few more times, and suddenly each node has this incredibly rich contextual understanding of its place in the whole system. Now, this ability to understand context and relationships isn't just some cool academic exercise. It's out there in the real world, transforming entire industries and solving problems that were practically impossible before. Remember Halicin from the beginning? That was a GNN treating molecules like little graphs of atoms and bonds to find a new antibiotic. And have you ever been on Pinterest and just been amazed at how it knows exactly what you're looking for next? Yep, that's a GNN called PinSage, mapping out the relationships between billions of pins. GNNs are also the reason Google Maps can predict a traffic jam before it even gets bad. It sees the road system as a massive graph. And in the world of finance, they are an absolute game changer for spotting fraud. You see, a single transaction might look totally normal, but a GNN can see the entire web of accounts and spot a suspicious loop of money that's trying to hide its tracks. As incredible as all this is, we have to remember, this technology is still pretty young. It's evolving fast, and it definitely has its own unique set of challenges that researchers are working hard to solve right now. So, one of the big hurdles is a problem called oversmoothing. The best way to think about it is like that game of telephone we played as kids. If you let that message passing process go on for too long, the information from faraway nodes gets so mixed up and averaged out that eventually every node starts to say the same thing. Their unique identities get totally washed out, and, well, that's not very helpful, is it? Which brings us to a final, pretty mind-blowing thought. For the very first time, we have a type of AI that is specifically built to understand networks. And networks are the basic structure of almost every complex system we know. Now that we have a tool that can actually map these relationships, the most complicated systems in our universe, from the wiring of our own brains to the cosmic web that holds galaxies together, are suddenly starting to look a little less mysterious.